Hi everyone, I'm teacher Ije. Welcome back to our YouTube channel. Today, I'd like to talk about past year question for NMOS 2012, which is about the bird head model. Everyone, let's have a look. So from this question, we know that in the figure below, each side of the smaller quadrilateral ABCD is extended to twice its original length. Or we say that the ABCD here, you see that the length is extended. AB extended, BC also extended, twice of it. We say that by connecting the vertices, we obtain a larger quadrilateral WXYZ. Thus, we know that AX is equal to 2AB. Oh, everyone, the whole AX here is equal to 2AB. Oh, so what can we notice from here? What is the ratio of AB to BX? We know that it will be 1 to 1. In fact, all of the other lengths here, BC to CY is also 1 to 1. CD to DZ is also 1 to 1. DA to AW is also 1 to 1. If the area of the smaller quadrilateral is 50 cm squared, we are asked to find the area of the larger quadrilateral. So everyone, how do we solve this question? Oh, you can see that in this question, we are given with the area of this quadrilateral. We need to find out the area of the remaining triangle right here. But how do we do that? Okay, everyone. Now, let's look at one example. So now, let's say we have this triangle right here. We are given with the triangle ADE. The area is 5. And we also know that the ratio, this is 1 to 1, AE to EC. And other than that, AD to DB, this is 1 to 3. Now everyone, based on the information that is given here, how do we find the area of the whole triangle ABC? You see, we are given with the area of one smaller triangle. We need to find out the remaining part. But you can see that the remaining part right here, the ECBD, this is a quadrilateral. You see that when we learn a lot of different types of the geometry model, most of the time, it is talking about what kind of shape? Or it is talking about the triangle, right? So now everyone, in this question right here, why don't we try to cut this quadrilateral to be some triangle? For example, we can try to connect the line from E to B. Now everyone, can you see any model here that can help us to find the relationship? That is actually the equal height model. Everyone, you see that the triangle EAB, and from the vertex E over here, it will cut through the triangle at this line. This is what we so-called the equal height model. We say that for two triangles that have the same height, the area ratio will be equal to the base ratio. Everyone, you know, in this question, AD, DB, the ratio is 1 to 3, which means that the area here is 5, then the area for EBD will be 3 times of it, which is 50. Alright, so we still have remaining one triangle that we have to find it out. Now F1, you see, for the whole big triangle ABC, that is also another equal height model. So you can see that from the vertex B, it will cut through from the line B to E. This is another equal height model. So we say that the triangle CBE, ABE, it will follow the base ratio AE to EC. And what? They have the same ratio, which means that the area, total area will be 20, which means that the whole triangle ABC will be equal to 40. Now everyone, think about it. Is there any way we can directly find out the whole triangle without have to apply the equal height model right here? Can we do that? Alright, now let's observe together. You see, we are given with ADE is 5. We are not able to directly get the relationship of ADE with the whole ABC. Just that we use the equal height model, right? So, now, how about we find out the ratio of ADE with ABE? What will it be? Now everyone, we want to find out the ratio of these two triangles. First thing first, the area of ADE, which side does it depend on? Which line? Oh, it will depend on AD, right? And how about the area of ABE? Which side it depends on? Oh, it will depend on the whole length of AB. So we say that it will be AD over AB. This is the ratio for these two triangles. Now the next thing, how about we find out the ratio of ABE with the whole big triangle ABC? Again, everyone, when we compare these two triangles, for example, ABE, which length does it depend on? It depends on which ratio? Oh, it depends on the ratio of AE. How about the whole big ABC? Which side does it depend on? Oh, it will depend on the whole AC. So it said that it will be the ratio of AE to EC. AE over EC. AC. Now everyone, in this example right here, are we able to get the ratio of ADE to ABC? Oh, everyone, you see that when we try to multiply them together, here there is a denominator ABE, here there is a numerator ABE. When we multiply the two fractions together, the denominator, the numerator, the ABE will be cancelled out. And what we have is ADE over ABC. So from here we know that it will be AD times AE over AB times AC. And you can see that AD times AE, what is it? Oh, AD is over here. AE is over here. 1 and 1. How about ABAC? Oh, the whole AB here is 4. And the AC here is 2. So we have 1 times 1 over 4 times 2, which is 1 over 8. Everyone, from here we know that the small triangle AD with the whole big triangle ABC, the ratio is 1 to 8. Which means that it will get the same answer, 8 times 5. We got the answer is 40. Alright, so this is how we directly get the relationship between the small triangle and the whole big triangle. And everyone, this model right here, we call it the bird head model. You see, what do we call it a bird head model? You see that, isn't that it looks exactly like a bird head. You can see that in front of it there is a beak of the birds right here. We call it the bird head model. And what is the characteristic of this kind of bird head model? Everyone, we say that the triangle ADE and ABC, both of it, they have the common angle, or we say that they share the same angle over this part. So from here, the conclusion of bird head model is that if we want to find out the area ratio of AD and ABC, which is the small triangle and the whole big triangle, it will be equal to the product of two sides of the triangle. You see that AD and AE is the side of the small triangle. AB and AC is the side of the big triangle. This is about the bird head model. Now everyone, let's look at one more example right here. Now you can see that in this question, oh, we have this kind of two triangles. We again want to find out what will be the area ratio of ADE to ABC. But how do we want to find it? You see that just now we learned about the bird head model, but in this example right here, it doesn't even look like the bird head model that we have just learned. How are we going to solve this question? How do we find? So everyone, you see that in this question, we say that, oh, we can try to connect one line for this part. Because for our basic bird head model, we say that we need to have one triangle inside the big triangle. So we just have to draw one line such that AD will be equal to the AD prime right here. The two triangles have the same base, so we say that they have the same height, or they are the same area. So now we will have just like the basic bird head model. So in order to find out the area ratio of AD to ABC, we say that, oh, now the AD here will be identical to the AD prime E. So from here we know that it will be just AD prime times AE over AB times AC. And we just say that the length of AD and AB, it will just be the same. So we change the AD prime back to the AD. Oh everyone, so we come up with the same conclusion like what we have get just now from our first example. So actually this is also what we so-called the bird head model. It's just that it is another variation of it. But isn't that just now we say that the two triangles might have the common angle, same angle. But in this case, do we have the same angle? Oh, actually everyone, Another characteristic to be the common angle is see that these two angles, what is the sum of it? 180 degrees. We say that the characteristic of the Bird model to have the common angle. The first one is to have the same angle. The second one is to have the sum 280 degrees. So we'll get the same conclusion such that the area ratio of the small triangle ADE with the big triangle ABC, it will be AD times AE over AB times AC. So this is all about the Bird model. Everyone, now let's go back to our question. Alright, so now let's observe together. We want to find the relationship with all of the triangle here for the quadrilateral. But just now you see that we learned about the Bird model. It is about the triangle. Again, what should we do in this question? We try to connect some line to see whether we can find out some model right here. Everyone can see that after we draw out one line, actually there is some Bird model right here. First thing first. This is one of the Bird model. Anything else? Everyone, that is another Bird model over here. Now you can see that if you like to find out what is the relationship of the two triangles using the Bird model, let's say we find out the yellow triangle here. The ABC and the triangle BXY. What will be the ratio? Everyone, we just say that this is 1 to 1. This is also 1 to 1. So you can see that the small triangle, we use AB, we use BC. So we have 1 times 1. For the big triangle, here that is 1. And the total length here will be 2. So we have 1 times 1 over 1 times 2. The ratio will be 1 to 2. What can we know from this ratio? Everyone, let's say I name these two areas right here, area 1 and area 2. Now, everyone, what will be the area for BXY? We say that the ratio is 1 to 2, which means that it will be 2 times of the area 1. Now, how about the area of the remaining triangle here, DWZ? What will be the area? Everyone, you see that we don't even have to manually calculate again because all of the triangle here in this question, the ratio is the same. 1 to 1, 1 to 1. So without further calculation, we know that it will be 2 times of the area 2. So now you can see that the summation of these two triangles, what will it be? It will just be 2 times the area 1 sum up with the area 2. And everyone, what is the sum of area 1 and area 2? The small triangle is just, the small quadrilateral is just equal to the 50 centimeters square. It will be 2 times 50, it is 100. Now everyone, isn't that we still have 2 triangles that we have to find it out? Now, let me have another figure right here. You see that just now, we cut it the line from A to C. We get 2 Bird model. What if we try to cut it in another way? We cut it from D to B. Now we have another 2 Bird model. You can see that this is one of our Bird model, and we have another Bird model on top of it. Okay, everyone, let's say this is area 1, this is area 2. Now, what will be the area of WXA and the area of CYZ? Everyone, this is just 2 times of area 1, this is 2 times of area 2 because of the same ratio. So we say that the sum of these two triangles is also equal to 100. So to find out the area of the whole figure WXYZ, it will just be 100 plus 100 plus the 50, the small quadrilateral in the middle. So the answer will be 250 centimeters squared. And this is our final answer. Alright, so let's summarize what we learned from this question. First thing first, we say that we learned about 2 different variations of our Bird model. So the characteristic of the Bird model is that we need to have the common angle. So the common angle refers to the same angle or the sum 280 degrees. So for this, we will come up with a conclusion such that the area ratio of the triangle ADE and ABC, it will just be equal to the ratio of the product of AD times AE over AB times AC. It is the 2 sides of the triangle. Alright everyone, so now you can try to do this practice question and you can leave your answer at the comment section below. So you may join our WhatsApp group for more information about our activity. I hope you enjoyed this video and don't forget to subscribe to our YouTube channel. See you in the next video. Bye bye.